Course 1 Math Lesson 3 extends our information about addition, subtraction, multiplication, division problems, and takes away one of the numbers from the operation to see if we can't solve the mystery for what we call the unknown number, the mystery, missing, variable, changing, unknown number. Okay, so skipping past the mad minute, mental math, problem solving things we do in person in class for our video lesson. New material starts at the very bottom of page 18. The nice reminder of the terms addend and sum in this example addition problem, 4 being one of the numbers being added, 3 being a number being added, so they're addends, 7 not being added, it's the answer to an addition problem called a sum. Okay? Now what if we were missing the number 3? And they said 4 plus what is 7? 3 would be called an unknown because we don't know its value. And you can show an unknown as a letter. Like here they have an M to show that it's missing. We don't know what that number is. So in our math notes, I want the term unknown, where the value isn't known. Maybe you can show the example 5 plus M is 7 or something. And you could circle the M because that's our unknown, a number we don't know the value of. And we can show unknowns, or eventually we'll just call them variables, with capitals or lower cases. It doesn't matter. It just needs to not be a number so we don't get confused, because there is no value to it until it's been solved. We could solve this, and there's different ways we can do that, addition being easier because of that commutative property. If I needed to solve a missing or unknown number in an addition problem, let's say the 12 was missing in the problem, what plus 19 is 31, we're missing an addend. To find it, how could we answer that question? How could we find that if we didn't already know it was 12? Well, with addition problems, to find an addend, you can take your sum, subtract one addend, the known addend, to find the unknown, other addend. Don't believe me? And maybe you've done this before, bear with me if you have. To find a missing addend, take sum minus known addend to find unknown addend. Pretty cool, huh? And if the 19 had been missing, right, according to fact families, we know that we would get the other one. So to find the missing sum, you can do that, or the missing addend. If they're all in a row like this, and we've got a lot of them, no big deal. How could we solve for any of these numbers missing? Same thing as before. You take your sum and you subtract all the known addends to find the unknown. So in your book, they show that on page 19. And instead of covering it, they use an unknown, a letter, the letter N for the 6. And they say, what's the value of N? How would we solve? We add all the known addends, 36, 17, and 5, which comes to 58. That's these three. And you take that away from 64, and 64 minus 58 is the missing 6. Subtraction, I said, was going to be a little more complicated because it's not commutative. Review, what is the 8 called in a subtraction problem like this? It's the minuend. It's the number we're taking away from. What's the 3 called? It's the subtracting number, the taking away number, the subtrahend, subtrahend number. And finally, what's the answer in a subtraction problem? It's called the difference, okay? And if I covered up the, let's say, the subtrahend, how could I solve what it's worth? That missing member of the fact family, I would take simply minuend minus difference to find the missing subtrahend. What if I'm missing up here the minuend? I just know subtrahend and difference. How would I solve? Can I just subtract the way I did before? The known number and the difference? Well, to find the missing subtrahend over here, we subtracted the difference from the minuend. Over here, finding a missing minuend, we add the other two numbers. Because if I did 24 minus 16, 16 minus 4, whatever, I would get 8. And 8 is not what I want. 8 does not work up here, does it? It was over here, which was what made me think for a second maybe it did work. It does not work. 8 minus 16 is negative 8. 16 minus 8 is 8. We're trying to get to 24. So we can't follow the same pattern in subtraction for both if we're missing one or the other. Missing this number is easy. Just 8 minus 5 is 3. But missing this number, let's use an x. We can't just subtract. Instead, at the bottom of page 19, if there's one sentence you remember today, remember this one. We can find right here. Find a missing minuend by adding the other two numbers. Adding to solve an unknown number in a subtraction problem. That can be easily confused. Not always an obvious thing. So let's add instead 24 plus 16 to get that top number, which is supposed to be the biggest number. So it kind of makes sense we want to add to get to it. Check our answer. How? Plug in what you say x should be to make sure it works. Maybe in a calculator you type 40 minus 16 equals, and it should show 24. So one more time with me. To find the missing minuend in a subtraction missing a number problem, you add the difference with the subtrahend. And in this case, that came to 40. Last example 4. Let's just talk it through here. 236 minus an unknown is 152. Find the value of y. One way to determine how to find this missing number is to think of a simpler problem that's similar. It doesn't have to be the way we just showed you. Maybe you just think, well, 5 minus 3 is 2. So in the same sense, I would obviously, missing the 3, do 5 minus 2 to get 3. So I'm going to do 236 is in the place of 5 minus 152 in the place of 2 to find my y. 236 minus 152 is 84. So they're saying we use the same process, but to get there, instead of memorizing it, maybe you just use really tiny numbers in place of the big scary numbers to remind you, oh, well, obviously I'm going to do it in this order. How can we check? Use 84 in place of the y. 236 minus 84 is 152. Can you think of another way that we would check that subtraction? Well, we could add 84 and 52 according to fact families. It should come to 236. An equation is the last word I want to mention today. An equation is a math sentence that uses an equal sign, the symbol with two parallel lines right next to each other, which is easy to remember because equation literally has equal sign in the name, right? Equation is a math sentence that uses an equal sign. Could be something as simple as 5 is 5. A lot of times I use is instead of equals or equal to. 2 plus 3 equals 5. This is an equation. An equation is a math sentence setting two amounts equal to each other. For your proof that you understand what we're doing here in this lesson practice, analyzing, finding unknown numbers in each, and checking, however which way you wish. Pick 3 from up here and 3 from E through I, okay? To do 6 total of these. Thank you.